Okay, yes, can't hear you. Look on my desk. So I wrote on the board and I sent an email out this morning. Your final exam is scheduled for Thursday, January 19th at 1 o'clock in the afternoon. That is different than what's on the final exam schedule. Okay? And the reason for it is because I'm away the last week in January marking diploma exams. So we have to have the exam early so that I have time to mark it, get all the stuff put into PowerSchool, and finalize your grades. Also remember, that's the same day, Thursday, January 19th, that missing assignments are due. After that, they go in as zeros and your mark's going to go down. If you can get your mark up to 75 or maintain that grade, you don't have to write the final exam. So if you're close, if you're on the bubble, and you have assignments that are outstanding, you better get them in before that date so that I have time to mark them and get them into PowerSchool so we know what your mark is, so you know if you are exempt from the final exam or not. So you want to give yourselves a few days extra time there, get your stuff in early so that I have time to mark it and get it in so you know whether you're exempt from the final exam or not. It'll only matter if you're kind of on the bubble. All right? So today we're going to start reviewing for the final exam. And the first chapter that we did was surface area, volume, and capacity. And this is an example of the formula sheet that we used for this course. Okay, so it's got some formulas on there as well as some conversions that we would use to convert. So this first example says convert each of the following. We want to go from cups to quarts. So if we look on our formula sheet here, we don't have a formula going from cups to quarts. What we do, though, is we have a formula that goes from gallons to quarts, cups to ounces, quarts to pints, pints to cups. So what we would have to do is we'd have to first convert the cups to pints. Okay? So we are told that 30 cups is equivalent, let me back up here. We are told that 2 cups is equivalent to 1 pint. In this case here, we have 30 cups. So what we're going to have to do first is convert that into pints. Yes, on my desk. It may not be a pencil there, you have to use a pen. All right, so, when we've done these before, sometimes we've cross-multiplied to find out what the missing value is. But in this case here, if we look at the relationship, the number of pints is half the number of cups. 2 cups is equal to 1 pint. So the number of pints is half the number of cups. So in this case here, the number of pints would be half the number of cups. X would equal 15 pints, half the number of cups. And now we want to go from that to quarts. And if we look at this relationship right here, again, the number of quarts is half the number of pints. There's 1 quart in 2 pints. The number of quarts is half the number of pints. So in this case here, if we have 15 pints and we want to change that to quarts, it'll be half of 15, or 7.5 quarts. All right, so there's the answer to question A. Question B, you want to go from liters to milliliters. And you should know that there are, in fact, it says up here, 1 liter is 1,000 milliliters. So 20 liters would be 20,000 milliliters. There are 1,000 milliliters in a liter. Question C, you want to convert from cups to fluid ounces. Well, if we look at this relationship up here, the number of fluid ounces is 8 times the number of cups because there are 8 ounces in each cup. So 2.5 cups, you'd have to multiply that by 8 to get the number of fluid ounces in 2.5 cups. So I think that is 20. Let's just check that. 2.5 times 8. Yep, 20 fluid ounces. And the last one, going from quarts to gallons. So if we look up here in our conversion, the number of quarts is 4 times the number of gallons, or the number of gallons is 1/4 the number of quarts. To go from 4 quarts down to 1 gallon, you'll divide by 4, or multiply by 1/4. We can divide by 4, so we'll take the 18 and we'll divide it by 4, and that'll give us a number of gallons. So 4.5 gallons. Right? So that's how those questions are done. These next examples deal with surface area. So we'll look up above for our different formulas. And one thing you do need to know is what each shape is. That first shape is a cylinder. And the surface area of a cylinder is 2 pi r squared plus 2 pi rh. So a cylinder has circular top and bottom. The area of one circle is pi r squared. The reason this formula has 2 pi r squareds is because a cylinder has a circular top and bottom. There's a circle on the bottom, a circle on the top. Each circle is pi r squared for an area, but there are 2 of them. That's where the 2 pi r squared part comes from. The 2 pi rh part then is for the rounded side of the cylinder. Sometimes it's important to know that, what each different part of the formula comes from. So the radius, and in this case here, you're not given the radius, you're given the diameter to be 30 centimeters. The radius is half of that. So the radius is 15 centimeters. And the formula says that it's 2 times pi times the radius squared. So the radius has to be squared. The other part of the formula involves 2 times pi times r, the radius, times h, which is 10 centimeters. So note for that second part, nothing is squared, only in the first part. So most calculators will do order of operations for us. I have 2 times pi times 15 squared plus 2 times pi times 15 times 10. So you put it all in there once and it gives you your surface area. It tells us to round to the nearest square unit, the nearest unit, which in this case would be 2356. Okay, the digit to the right of the 6 is a 1, which means the 6 stays the same. 2356. And area is always in units squared, so it'll be centimeters squared. Okay, question B, that is a cone. And the surface area of a cone up above is pi r squared plus pi rs. So r is the radius, which we are told is 8 centimeters. S refers to the slant height. That's the length of the edge, which we are also given. That's 17.9 centimeters. So we can just put all these numbers into the formula. Pi times the radius of 8 centimeters, that's squared, plus pi times the radius again, times the slant height of 17.9. So again, all these numbers can go in our calculator. Pi times 8 squared plus pi times 8 times 17.9. Whoops. Press something wrong there. Have to start over. So pi times 8 squared plus pi times 8 times 17.9. So to the nearest square unit, that would be 651, right? The ones place is a 0, but to the right of that is a 9, which means the 0 has to go up to a 1. So approximately 651 centimeters squared. Area is always in units squared. Okay, so you got to know by looking at a shape what type of shape that is so that you get the right formula from the formula sheet. Question C is an example of a triangular pyramid because the faces are all triangles. If we look at the formula sheet, we don't have a formula for, well, I guess we do. Surface area of a pyramid is length times width, so that's for the base, the bottom. And then you have 4 triangular faces. And if the base is a square, then we can just find the area of one of the triangular faces multiplied by 4. But if the base is a rectangle, then we've got 2 different types or 2 different parts to the formula because you have 2 different sets of equal triangles. So if we look at this one here, it is a square-based prism or pyramid because the base is 7 by 7. So the first part of this will be 7 feet times 7 feet. So that is for the base, which is a square, plus we're also going to have the area of the 4 triangular faces. And the formula for area of a triangle is base times height divided by 2. But in this case, there are 4 of them. So it's 4 times a base of 7 feet times a height of 8.7 feet divided by 2. The formula for area of a triangle is base times height divided by 2. But again, there are 4 of these triangular faces, so that's why we have the 4 here. Now we can simplify this a little bit. This 4 divided by the 2, 4 divided by 2 gives us 2. So that just simplifies it a little bit. And now we'll go to our calculator to work this out. So we've got 7 times 7 plus 2 times 7 times 8.7. So that would be 170.8 square feet. Okay, so there's the surface area of that one. The last one is a rectangular prism. And the formula for the surface area of a prism is twice the length times the width plus the length times the height plus the width times the height. So I'm using this formula at the top for surface area. Okay, so let me just copy this here. Okay, so there's the formula I'm using for question D. So I just have to designate what my length, width, and height are. So I think it's fairly obvious that we would say that L, the length would be 30. We'll say that the width is 7 and the height is 10. So the first part inside the triangle is length times width. So it'll be 30 times 7. And I'm not going to put my units in here just so I can save some room. The second part inside the bracket is length times height. So that'll be 30 times 10. Plus the last part is width times height. So it'll be 7 times 10. So inside the brackets, if I work that part out, it'll be 30 times 7 plus 30 times 10 plus 7 times 10. So that'll be 580. And now I can put my units in here. That'll be centimeters squared, which when multiplied by 2 gives us 1160 centimeters squared. Okay, so there's the surface area of that prism. Now we want to find volume. The first shape is a sphere, a ball. And if we look on the formula sheet, the formula for volume of a sphere is 4 pi r cubed over 3. So that's what we need to use here. So we need to know the radius of the sphere. In this case, we're given the diameter. The diameter is 15.6. So the radius would be half of that. So if I take 15.6 and divide it by 2, that gives us a radius of 7.8 inches. So it'll be 4 times pi times 7.8 inches. That number needs to be cubed because the formula tells us that, all over 3. So 4 times pi times 7.8 to the power 3. And then that's all divided by 3. So that gives us an answer of 1987.798769. If I round it to the nearest unit, it'll be 1988. And that is in cubic inches, right? Volume is always in units cubed. Part B, that is a pyramid because it has 4 triangular faces. So if we look for the formula for the volume of a pyramid, it's length times width times height divided by 3. That's the formula that we would use. So volume equals length times width times height all over 3. So if we say that the length is 5 inches times the width, which will be 2 inches, times the height of this, which is also 5 inches, and then that's all divided by 3. So 5 times 2 times 5 gives us 50, divided by 3 would be approximately 17 cubic inches when you round it to the nearest inch. Actually, this one says to the nearest tenth. So let's fix that. It would be 16.7 inches cubed. And the last one would be 1987.8 when you round it. 1987.8 when you round to the nearest tenth. Now for this last shape, we call that a composite shape because it's 2 different shapes put together. The bottom part would be a prism. So let's say that that is volume 1, the bottom part. The top part is also a prism, but it's a triangular prism. So for volume 1, it's a box basically, and the volume of a box, if we look on our formula sheet, is just length times width times height. That's a rectangular prism. Length times width times height. So length times width times height. So we'll say the length is 7 meters, the width is 3 meters, and the height of this would be 2 meters. That's this part right here. That shows the height of the box on the bottom. So 7 times 3 is 21, times 2 would be 42 cubic meters. 7 times 3 times 2, 42 cubic meters. And then, as we said, the top part is a prism as well, but it has triangular faces. So if we look on our formula sheet, the volume of a triangular prism is length times width times height divided by 2. So that's what we need to use here. So this has a length that's still 7. The width is still 3, but the height is 3 as well. So that 3 meters there represents the height of that triangular prism. So 7 times 3 times 3 is 63 divided by 2 would be 31.5 meters cubed. And now to get our answer, we'll add them together. The total volume will be found by adding these together. So if we add the 31.5 and the 42 together, we'll get 73.5. So there's the total volume of that shape, that composite shape. Example 4, at the Stampede, you can buy snow cones. The cones have a height of 8 centimeters and the volume is 42.4. Determine the radius of the cone to the nearest tenth. So we're given the volume of a cone, and if we look on our formula sheet, the formula for volume of a cone is pi r squared h over 3. That's the formula we're going to use. So volume equals pi r squared h over 3. And in this case, you're given the volume to be 42.4 centimeters cubed. We're also given the height to be 8 centimeters. We want to find out what r the radius is. We want to find out what r the radius is. So the first thing I would do is I would multiply both sides by 3. What that'll do, that'll get rid of the 3 on the right side that's at the bottom. The opposite of dividing by 3 is multiplying by 3. So the whole point of doing this is so that those 3's cancel. So on the left, I'll have 3 times 42.4, which is 127.2. And that will equal 4 pi r squared times 8 centimeters. So now we need to get the r squared by itself. We can divide both sides by 8 centimeters. So they'll cancel on the right. And on the left, we've got the 127.2 that will be divided by 8. Gives us 15.9. The other thing here is that we also divided by centimeters. So centimeters cubed divided by centimeters leaves us with centimeters squared. So next, I'll divide both sides by 4 pi. And we talked about this when we did these in class. When you divide the 15.9 by 4 pi, you have to put the 4 pi in brackets. Otherwise, your calculator will divide by 4 and multiply that answer by pi. It'll give you a much bigger answer than you should get. You have to put the 4 pi in brackets so that it multiplies by 4 and, divides by 4 and also divides by pi. So that gives us 1.265 approximately centimeters squared equals r squared. And now to find out what r is, we take the square root of both sides. It does say to the nearest tenth to 1 decimal place. So I'll take the square root of that number, and it's approximately 1.1 centimeters. Right, we're rounding to the nearest tenth. The digit in the tenth place is the 1. To the right of that is a 2, which means the 1 stays the same. So there's that radius that's missing. Okay? So I have an assignment for you to work on. I will post the solution to this assignment on Google Classroom so you can check your answers. So remember, and I'll continue to remind you, our final exam is scheduled for Thursday, January 19th at 1 o'clock. This is different than what's on the